Okay, so we're going to look at POD 8.8, radical equations. Solve the following equations for the variable and always check your answers, because with radicals we can always get some pretty interesting solutions, maybe some extraneous things. So a good thing to do is have your radical isolated, which it is. To undo that, we could square both sides of the equation, and that would give us x squared plus 1 equals x minus 3 all squared. Make sure I don't do some silly distribution here. I need to actually distribute this out. That's x squared plus 1 equals x minus 3 times x minus 3. That's x squared plus 1 equals x squared minus 6x plus 9. I can get rid of the x squareds. They're on both sides. So I get 1 equals negative 6 plus 9. Subtracting 9, I should get negative 8 equals negative 6x. So 8/6 equals x. So 4/3 equals x. Okay, now I'm going to check my answer by plugging it back in. So is 4/3 squared plus 1 in a square root equal to 4/3 minus 3? Well, this is the square root of 16/9 plus 1. Does that equal 4/3 minus 12/3? Well, this right here is going to be the square root of 16 plus 9 is 25/9. Does that equal 4/3 minus 12/3? Well, the square root of 25/9 is the square root of 25 divided by the square root of 9, which is 5/3. Does that equal 4/3 minus 12/3? 4 minus 12 is negative 8/3? No. So this is an extraneous solution. In other words, there are no solutions to this equation. Okay, graphically what that's saying is that this radical never crosses this line. Okay, so this is some radical, and then this is some line, and they just never cross. Okay, moving on to B. I've got 2m plus 1 to the 3/4 power equals 8. I'm going to raise both sides to the 4/3 power, so that should give me 2m plus 1 equals 8 to the 4/3 power. Now I've got 2m plus 1 is equal to 8 to the 4/3. Remember, 8 to the 4/3 is the cubed root of 8 to the 4th, or 2 to the 4th, which is 16. So 2m should equal 15. So m should equal 15 halves, or 7.5. Okay, checking my work. I get 2 times 7.5 plus 1 all to the 3/4, and I want to know if that's 8. 2 times 7.5 is 15, plus 1 is 16. Is 16 to the 3/4 equal to 8? I'm going to say that yes, it is. So 16, 4th root of 16 is 2, cubed is 8, so I get 8 equals 8, and that is correct. Okay, this is a 4th root, so I should just expect one solution. So I'm pretty sure that this is my one solution, n equals 7.5. I'll just sort of cross this one off because I know that it's extraneous. There is no solution to this equation up here. Okay, moving on to C. I've got a cubed root, so why don't I cube both sides and get 3x plus 4 equals 7 cubed. Let me find 7 cubed on my calculator, make sure I've got that. So that's 343. So I get 3x plus 4 equals 343. So 3x equals 339. So x is equal to 339 divided by 3, which is 113. If I plug 113 back in here, I'm quite sure it's going to work. Cubed root of 113 times 3, which is 339, plus 4. Does it equal 7? Well, does the cubed root of 343 equal 7? Yes, 7 equals 7. Okay. Moving on to D here, I've got 5 times the cubed root of n plus 12 equals 2 times the cubed root of n. So let's see here. Well, that should be 12 equals, if I subtract this one, negative 3 times the cubed root of n, right? Because 2 minus 5 is negative 3. Dividing by negative 3, I get negative 4 equals the cubed root of n. Cubing both sides, I get negative 64 equals n. Checking my work, 5 times the cubed root of negative 64 plus 12, does it equal 2 times the cubed root of negative 64? Cube root of negative 64 is negative 4, so is 5 times negative 4 plus 12 equal to 2 times negative 4? Negative 20 plus 12, does it equal negative 8? Negative 8 equals negative 8. Yes, so that is a correct solution. E says square root x plus 1 minus 5, all times square root x plus 1 minus 7 equals 0. Hint, use the zero product property, no distribution necessary. Right, I've got two things multiplied to be 0, so I can just take one and set it equal to 0, and the other and set it equal to 0. Now adding 5, I get the square root of x plus 1 equals 5. I should have one solution to this because this is a positive number and even roots cross positive numbers once. So squaring both sides, I get x plus 1 equals 25, so x equals 24. Over here, I would get square root x plus 1 equals 7. Squaring both sides, x plus 1 equals 49, so x equals 48. I'm going to check in my head. 48 plus 1 is 49. Square root 49 is 7. 7 minus 7 is 0. 24 plus 1 is 25. Square root 25 is 5. 5 minus 5 is 0. And using the zero product property, those are both legit solutions. Finally, F, I've got the 8th root of p minus 9 over 6 equals negative 1. So the 8th root of p minus 9 should equal 6 times negative 1, which is negative 6. So the 8th root of p should equal 3. 8th roots cross positive numbers once, so this should have a solution. I'll raise both sides to the 8th power and get p equals 3 to the 8th power. So p equals 3 raised to the 8th power, again, is 6,561. Okay, plugging that in, 8th root of that is 3. 3 minus 9 is negative 6. Negative 6 divided by 6 is negative 1, so it checks out. Okay, finally moving on to problem number 2. Find 2 points on the line x equals 7 that are 8 units away from the point 3, 0. Hint, if in doubt, draw it out. Well, 1, 2, 3, 4, 5, 6, 7. That's the line x equals 7. The point 3, 0 is right here. We want to find a point that is 8 units away from that point. Well, let's think about what we know. 1, 2, 3, 4. I know from 3 to 7, this is 4. I know this is 8. And this is what I want to find right here, right? Let's call this y. Right? I already know that this x value right here, x has to equal 7 because it's on the line x equals 7, but I need my y value to know what that point is, and then this would be the negative y value. So using the Pythagorean equation, I know that 4 squared plus y squared has to equal 8 squared. So y squared equals 64 minus 16. So y squared equals 48. So y equals the square root of 48, and y equals negative square root of 48. Right, these two right here. And 48 divided by 4 is 12, divided by 4 again is 3, so this is square root 16 square root 3, so y equals 4 root 3. And so our points would be 7 comma 4 root 3 and 7 comma negative 4 root 3. Finally, 3 says if the area of the larger rectangle is 91 square feet, what is the area of the smaller rectangle? Okay, let's see here. So what I know is that the square root of x minus 5 plus 3 times 7 equals 91. right? Because this length times this, the larger rectangle, has to be 91. So that means square root x minus 5 plus 3 equals 91 divided by 7. 91 divided by 7 is 13. So the square root of x minus 5 has to equal 13 minus 3, which is 10. So x minus 5 has to equal 100, squaring both sides. So x has to equal 105. Okay, plugging that into my little rectangle here, what I now know is that the diagonal of the rectangle is the square root of 105, and this length is the square root of 100, which is 10. So I need this side length to be able to find the area of the little rectangle. So I know that 10 squared plus, we'll call this h squared equals square root 105 squared, which is 105. So h squared equals 105 minus 100, which is 5. So h equals the square root of 5. So then the area of the rectangle is 10 times root 5 feet squared. Great, and that takes care of POD 8.8.